In the context of regression, or even just basic prediction of the mean, we have not only confidence intervals, but also prediction intervals. So, what's the difference? What is a typical confidence interval that we're used to? If we have a regression equation where we're predicting weight from height, like this, a 95% confidence interval is an interval that is likely to contain a parameter, like the slope. We could say something like we are 95% confident the slope beta is between 4 and 6. From our typical perspective, there are two main parameters we are trying to estimate, the slope and the intercept. We also have to estimate the error variance, but let's forget about that for now. If we expand our perspective a little, this equation actually defines infinitely many parameters. The slope and intercept define an entire line that gives us estimates of weight for people of every possible height. So alpha plus beta times height gives us the expected weight for every possible height. What is the expected weight for someone who is 72 inches tall? That is defined by this line. Without thinking of the mathematical details, I can say that I'm pretty confident the average weight of someone who is 72 inches tall is between 180 and 250 pounds. I could say something like I'm 95% confident that the average weight is between 180 and 250 pounds. If I collected a lot of data, I think I could narrow this down even further. If I measure millions of people, I could say I'm 95% confident the average weight for a 72-inch tall person is between 205 and 210 pounds. Knock, knock. Oh, someone's at the door. I'm 72 inches tall. Guess how much I weigh? Well, I've collected so much data on this. I should be able to narrow it down. Can I say that I'm 95% confident that this dude is between 205 and 210 pounds? No, I can't. I was only able to figure out the average weight of people, but individuals' weights are all over the place. I could say something like I'm 95% confident that this person is between 140 and 300 pounds, but it's hard to narrow down. When I say I'm 95% confident the average weight for a 72-inch tall person is between 205 and 210 pounds, I'm making a confidence interval about the average weight of all people who are that height. But when I'm trying to predict the height of a single individual, and I have trouble narrowing it down, that's a prediction interval. The prediction interval is wider than the confidence interval because of this inherent uncertainty. Here's another example. Let's take a look at pizza delivery times. We can make a confidence interval for the average delivery time. And if we tracked thousands of deliveries, we could precisely estimate the average delivery time from a particular restaurant to your neighborhood. And we could do it pretty precisely. However, if I'm trying to predict the exact delivery time of a single future order, there's a lot of inherent uncertainty with the traffic, the weather, and other factors like how many orders they have at that time. So it's hard to predict the exact single time of one future order, but it's easier to predict the average time. We can see this in the formulas. Here's a formula for a 95% confidence interval for a mean. The standard error is S, the standard deviation, over the square root of n. We could also write it like this. But a 95% prediction interval has a wider standard error, a wider margin of error. It has extra variability. This 1 is being multiplied by the S because we have the additional inherent standard deviation that all observations have. Because we're not just trying to predict the mean, because we're trying to predict the actual outcome of a single individual, we have extra uncertainty that shows up in the formula. And often, in the context of regression or other things, when we see the formula for a prediction interval, it will have this extra 1 in it, which tells us that the interval is wider. Thanks for watching. Please like and subscribe to learn more statistics.